Now we'll review a couple of bonus questions. A palindrome is a string whose reversal is identical to the string itself. So it's the same if you read it forwards or backwards. The following are examples of palindromes, or palindromic strings of characters, or bits maybe. 0, 1, 0. Backwards it's 0, 1, 0. This 0, 3, 4, 4, 3, 0. Same forward and backwards. ABBA, ABBA. 1, 1, 0, 1, 0, 1, 1. All right. So notice this has an odd number of bits, 1, 2, 3, 4, 5, 6, 7. So it has a middle bit. Even if I changed that 1 into a 0, this would still be a palindrome. It would be 1, 1, 0, 0, 0, 1, 1. When they're even number of bits or characters, the middle two have to be identical. 4, 4 here, B, B here. Okay, how many strings of 11 bits are palindromes? That's my picture. Well, let's just count the strings. I'm going to go left to right. I could go right to left, but I'm going to go left to right. How many choices do I have here? Well, they could be anything I want. 2 choices. 2 choices, 2 choices, 2 choices, 2 choices. 2, 3, 4. 2 choices. But now, notice that's the middle bit of the 11 bits. Okay? So how many choices do I have for this one right now? Do I have 2 choices? Can it be anything? No, it can't. It has to exactly match whatever this one is. So I have no choice. If this is a 0, this one has to be a 0. If it's a 1, this has to be a 1. So this one doesn't represent a bit value. It just represents the number of possibilities. It has to match exactly what that one is. And this one has to match this one. This one has to match this one. This one has to match this one. And this one has to match that one. Okay, so that's the answer. 2 to the 1, 2, 3, 4, 5, 6. 2 to the 6th power, which I think we already did, was it 64? 2, 4, 8, 16, 32, 64. Okay, next bonus question is, the local buffet sells a Saturday night meal deal. 16 bucks. That has nothing to do with the problem. The price doesn't. The buffet consists of 6 different meats. Let me just write 6 meats, 7 different veggies, and 8 different drinks. This $16 meal consists of 2 meats, so you have 6 to choose from and you have to choose 2 of them. 3 different veggies, so you have to choose 3 out of these 7. And a drink, so 1 drink out of those 8 drinks. How many different meals are there? All we need to do is ask ourselves, this is one of those multiplication principle problems. How many ways can I do the first one? Times. How many ways can I do this one? Times. How many ways can I do this one? Well, I've got 6, and I have to choose 3. That's the combination of, let me see, was 3 the right number? Oops, sorry, 2 different meats. Out of the 6 meats, I have to choose 2. Times, out of the 7 veggies, 3 different vegetables. Choose 3. Times, I'm not even going to write that out. We're choosing 1 out of 8. We all know that that's just equal to 8. I could have written it as the combination of 8 things taken 1 at a time, but we know that that's equal to 8. So that would give us, let's see, you can double check my math if you plug it into the formula here. 6 factorial over 4 factorial 2 factorial, we would get this, times 7 factorial over 4 factorial 3 factorial, oops, would be 7 times 6 times 5 over 3 times 2 times 8. All right, so 6 and 2 cancel, leaving a 3 upstairs. 3 times 2 is 6, so I'll just cancel that 6 out, leaving the 7 times 5 times 8. So we get 15 times 35 times 8. And I'm going to leave the answer just like that. That is how many different meals there are. You can multiply it out if you'd like.